Monosubstituted cyclohexanes mean they have a substituent replacing one hydrogen atom. So if you notice here, you have a methyl group replacing an H that was occupying this location right here. Now, of course, cyclohexanes are substituted. They can be mono, di, tri, whatever it is, substituted. And we need to look at the methyl in this case, right here, CH3. And this methyl is now in the axial position. And if you notice, when it's in the axial position, there is repulsion going on between these H's right here, the axial hydrogens, and of course this methyl. So again, there's repulsion right here between this methyl and these H's. So you have repulsion. Right here. So this repulsion, okay, is called what we call a 1/3 diaxial interaction. So if we do a ring flip, we notice now that the axial methyl that was here is now there. So again, we're going to call this an axial methyl. And of course, this right here is now an equatorial methyl. And there's something remarkable about the equatorial methyl is that it has much more stability. These interactions or these repulsions are no longer existing here. Again, it's deceiving to you looking at it this way. You might say, oh, this one is bumping with that one, but you have to look at it from a Newman projection. You will see actually there's no, again, repulsions happening like that was happening in the axial. So in this case, we will say that this is more stable. And of course, if you notice here, the equilibrium shifts to the right. That's the equilibrium because it's more stable. Now, I'm not going to really belabor this because this is very hard to see. You'd have to really look at it very carefully with the models. But if you look at the 1/3 diaxial interaction, you would see that you would have a gauche butane. If you can trace it right here, if you have a gauche butane, and this one would have actually, when it's axially, if you look at it this way, axial methyl cyclohexane, you would have two gauche butane, two gauche conformations or interactions right here. And in this one, when you have an equatorial, there's no gauche interactions. Think about it before we meet next time. Try to imagine that there are a gauche butane. If you have a gauche butane, this is just a butane. Look at the axial methyl cyclohexane. Look at this one. Can you imagine the two gauche butanes that are happening here? The gauche interactions that are happening here between the methyl and, of course, and the hydrogen. So look at that very carefully. And of course, if you have an equatorial, they have no gauche interaction whatsoever. the one thing you need to remember is that the larger the substituent, the greater the repulsive interaction when it occupies an axial position. So the larger it is, the more area it's taking away from the other hydrogens. So in the next video, we'll talk about disubstituted and being able to draw those conformations.